Hello, so good day everyone. Today we're going to discuss a new lesson. No? We'll move on from kinematics na. So we're going to discuss work, energy, and power. So for work, energy, and power, we need to define first ano yung work, ano yung power, tsaka yung ano yung energy. No? So meron tayong two images dito. Isang tao, tinutulak niya yung isang unmovable object or isang wall. No? Tapos meron namang kabila dito, merong tao, tinutulak niya yung box. No? So, siyempre, eto si A, tinutulak niya yung wall, walang distance na nangyayari, no? Kasi siyempre, parang tinutulak mo yung wall lang. There's no movement, pero siyempre nakakapagod yan. Kasi siyempre, you're exerting effort to push down the wall, no? So, next one naman is we have another person here trying to push a carton box, no? Or a wooden pallet box, no? So, who exerts here more effort? Okay? So, by that this by seeing that ano ba ang definition ng work, ano ba ang definition ng energy, tsaka ano ba ang definition ng power. So work is defined as the product of net force, yung puwersa acting on a body and the distance moved in the direction of the force. So meaning if there is no distance that is created, no, if you push something tapos there is a distance, ang meaning nun there is work done. Okay? So, if there's work done, meaning, kapag may distance na nangyari, there's work that happened. So, meaning, in the picture number 1, the picture A, there's no work happened. No? Parang ka nagtulak, parang nonsense lang, nagtutulak ka ng pader. Diba? Wala ka namang work na nangyayari doon. But if this is your work, no, trabaho mo to, there's actually good money in doing this, no? Nagtutulak ng mga boxes to arrange them, maybe, no? If that is on your job description. So then there's work involved. Okay. So that is the work. So work is the force times the distance that is traveled. So in the SI unit, alam naman natin yung force natin as discussed, no? It is the Newton, no? So yung force natin is mass times acceleration. So we have our Newton. Then for our distance, we have our uh, meters, no? So if we're going to unit analysis that, joules kasi ang lalabas dyan, no? So, if we have Newton, yan, Newton, ang breakdown kasi niyan is kilogram per, ay, pangit tuloy na suot ko kasi mouse lang gamit ko, no? Kilogram multiplied by meters per second squared. Okay? So, if we're going to multiply that again by the distance, which is meters again. So we have kilogram, okay, per meter squared, meter squared over second squared. So that is your joules, no? So the unit breakdown of joules daw is 1 joule is equal to 1 Newton meter or 1 kilogram meter squared over second squared. So that is your unit breakdown for joules. Okay? So next one natin, yung kagaya kanina, yung discuss na natin na CA, there's no work done. No? While on the other hand, B, there is work done because there is a certain distance that was achieved, no? When pushing the box. Okay? So work, the only component of work applied force in the direction of the motion of the lawnmower, F horizontal, is used to do work on the lawnmower. So ito meron tayong, siyempre, if it is a diagonal work, kapag tinutulak mo on the sideways, you have F horizontal, we have the F component of horizontal, then we have the F component of vertical. Okay? So maulan, no? Kaya medyo inubo ako. So do excuse me if I have to cough. So yun lang. So meron tayong practice problems dito. If an object is moved with a force of 15 newtons on a horizontal surface, how much work is done when the object is moved of 50? So if we're going to multiply it, di ba kaganina yung ano lang natin, yung ang tawag dito? Yung formula natin is your work is equal to force times distance. So multiply mo lang, no? So meaning if work times distance lang, that is just 15. You multiply it by what? 50, no? So we have your 750 joules, no? Yun ang Sagot dyan. So, number 2, 650 joules of work is done in moving a desk of horizontal force of 5 newtons. How much force is used to move the desk? So, by triangle method, we can just divide it, no? We have 650 divided by 5, which is 130 newtons, okay? Pero if you don't want yan, if di mo naman gets paano nag-divide ng ganun, pwede naman. You just do the shift solve. Yan. Para 650. Tapos pwede mong i-alpha yan dito. Tapos pwede nating ilagay na we're finding for the force multiplied by 5. Okay? So we have a 171, meron tayong 130. Magkano kanina. Okay? So, magkano kanina? 650 divided by 5, we have 130. So, same answer. Just different process. So, how much work is done in lifting a 10 kilogram box of a 1.5 meter floor? So, we have 10 kilogram box, and this is the 1.5 meter of the floor. So, if we want to compute for this, diba ito, bigat to. This is your mass, no? So, this is the 1.5. How much work is done daw? So, if we're negating the pagbubuhat, no? We're actually counterweighting the gravity. So, that is 10. We can multiply it by the gravity, which is 9.81. Then we can multiply it by 1.5. We have the total work of 147.15 watts. Okay? So, ayan. Gaya nung kanina, how much done is work, kasi meron tayong gravity. Kasi you're actually negating gravity here, no? You're counteracting gravity because gravity is always acting upon us. If you're lifting something, you're actually counterweighting or you're actually counteracting gravity. Kasi 'di ba pababa lagi ang gravity. So kapag binubuhat natin, ano nangyayari? We counteract gravity. Okay? So next one natin. Ito, how much work is done again while walking 5 meters holding a object of 3 kilogram. So there's actually the direction of the applied force, then direction of motion, no? So ano ba yung ano natin diyan? What you can do is what? You can also multiply it by 9.81, then you multiply it by 5. Okay? So ito, meron tayong practice problem dito, no? So later on, I will send this for you to practice para magawa ninyo. Pero napakadali lang nito, no? If you are actually watching this, then madali nyo masasagutan to. Napakadali. So, next one natin, meron tayong power. So, power is the rate at which work is done, no? So, meaning, gaano kadaming na a-achieve na work, gaano kadaming nagagawang work in a period of time. Okay? So, yun daw ang ibig sabihin ng power. So, 1 watt is equal to 1 joule over second. So, meaning, power is equal to the amount of work done in a period of time. So, if for unit analysis, power is equal to W over T or is equal to force times distance over T or pwede ring Newton multiplied by acceleration times distance all over T. Okay? So, if we have, again, ito, 150 newtons multiplied to 10, power in watts. Okay? So, we can actually compute for this, no? Paano ba ginagawa yan? Okay? So, as you can see here, we have our newtons. So, ano nga natin? Pakumpay natin para meron tayong pen, no? So, mismong dito tayo mag-pen. Okay? Dito. So, if this is 150 newtons, okay? 150 newtons. Our formula kanina, ano yung formula natin? We have, balikan natin, force times distance over time or work over time ang power. Power is equal to work over time. So what we can actually do is we break down this, that is force multiplied by distance multiplied by time. If we apply this to the here, what's our force? It's 150 Newton. That's our force. The distance is 10 meters and the time is actually 20 seconds. So what we can do is we can multiply it, no? Basic na basic. we can force. What is force? Your 150 newtons multiplied by the distance, which is 10 meters. Then you divide it by time, which is 20 seconds. So what will be the answer? Ayan. Wait lang. Paano ba natin mapapalabas yung... Ay, nawala tuloy. So, ay, nakasulat kanina. Lagay lang natin. You can do it on your calculator. 150. Nawala tuloy. Wait lang. 150 multiplied by 10 meters all over the seconds, which is 20 seconds. We have 75. So, that is 75 watts. Okay? So, and pwede pala tayo maglagay ng calculator dito. Yeah. So, yun. So, we have another one. We have a 10 kilogram man, isang lalaking 80 kilograms. So, he runs up a stairs in 5 meters high in 10 seconds, no? What is the man's power output in watts? Okay? So, if we're going to do this, we must understand na ano yung unit natin, no? So, ang unit natin dito is 80 kilograms. So, if he's 80 kilograms, he's actually counterweighting the gravity again or counteracting the gravity. So, we need to multiply it by the gravitational constant natin, which is 9.81. So, if we're going to input this, we have 80 kilograms, 80 multiplied by 9.81. Yan. Tapos you multiply it again by 5. That is 5 meters. Then you divide it by 10 seconds. Because our formula is what? For watts, it is force times distance over time. So this is your force. No? This is your distance. Then this is time. Okay. So if we're going to input it in the calculator, that will be 80 multiplied by 9.81 multiplied by 5. No? As you divide it by 10. So your wattage is 392.4 watts. No? That will be the answer. So next one natin, number 3. A pump lifts 30 kilograms of water over a vertical distance of 20 meters. Each second, what is the power output? So, kagaya nung kanina natin, we have 30 multiplied by 9.81. Pwede rin idiretso sa calculator yan, no? That is 30 multiplied by 9.81 multiplied by the distance, which is 20 meters above the head. 20. So, ilang seconds daw? Each second. So, 1. No? So, that is 5,886 watts per second. Or, if you want horsepower, you can actually divide it by 746. So, ang pump natin is 7.9 horsepower ang kailangan niya para ma-lift yung 30 kilograms of water over 30 meters per second. Okay? So, ano daw to? Which person below does more work? No? And which person does more power? Explain. No? So, later on, I will also give this as an activity as part of your understanding. No? Kapag ba nagmamadali ka sa stairs, sino ang mas nakakapagod? No? Or ano ang mas madaming work? Tapos ano ang mas madaming power? Pag mas mabilis ba, mas madaming power? Or kapag ba mas mabagal? Or kapag ba mabilis, mabagal? Ayan, no? Para malaman natin kung ano yung relationship ng time, ng force, no? Sa power and work. So, next one natin, we have energy, no? So, energy is defined as the ability to do work. So, if we have a brick here, okay? If we have a brick, yan. If we have a brick, tapos, siyempre, mamumukok sa partilyo, ay sa nail natin, or if we have a hammer, and we have a nail, so, what is the definition of your energy, no? It is actually defined as the ability to do work, okay? So, two types of energy. We have kinetic and we have potential. So, anong ibig sabihin nun, no? Anong ibig sabihin ng dalawa? So, kagaya nung kanina, yung energy natin, the SI unit for energy is actually joule, no? we have your kilogram per meter per second squared. So that is your joule. So the kinetic energy, energy in the form of motion. So anything that is in motion is considered as kinetic energy. No? Pag in motion yan, considered as energy. So it is a scalar quantity because it does not it does not it does not depend on the direction, no? So that is the scalar quantity. So if we have the kinetic energy, yan, pwede na naman tayo mag-solve, no? So madami tayong solving, medyo madami. What is the kinetic energy of a 60 kilogram girl on skis traveling at 20 meters per second? So what is the formula? We have 1/2 mv squared. Lista natin dito yung formula natin, 1/2 mv squared, no? So we can actually have 1/2. Our m is 60. V is 20. Tapos square natin, no? So we have our pwede nating input sa calc yan, no? Pwede kayo mag-download ng calculator app sa phones ninyo, no? Kasi sa midterm exam, you need to borrow a calculator if you don't have one. If you have one, you can bring, no? Pero no phones during the exam, okay? So we have the kinetic energy of 12,000, no? Joules. Okay? So that is joules, no? 12,000 joules. So paano nangyari yon? If we're going to analyze it, that is 60 meters. That is 60 kilogram. Thus this is meters per second squared. Okay? So kilogram multiplied by meter, you have your what? You have your ano yan? Kilogram multiplied by meter. Ano yan sa tingin nyo? That is your ano yan? Okay? Kilogram meter per second, no? So we have ano ba ang formula ng joule, di ba? Kilogram meter per second over second squared. Okay? So yun ang unit breakdown, no? Para maintindihan ninyo mabuti. Okay? So ito so velocity kasi natin, ito, squared din to, no? Kasi nga may squared tayo dito. I-distribute yung squared niya. So kilogram per meter squared over second squared. Okay? So next one natin, a sports car is moving at 4 meters per second. If the mass of the car is 800 kilograms, how much kinetic energy does it have? So again, meron tayong direct formula lang dito. We can actually input it as 1/2 multiplied by 800 multiplied by your 4, and this should be squared, no? So if we're going to input it, we can do 1/2. So that is 800 multiplied by your 4 squared. We actually have 6,400 joules. Okay? So that is your kinetic energy. Next one naman is we have our potential energy. Okay? Potential energy is the stored energy. The compressed spring has potential energy because when it releases, it can do work. So if there is a stored energy, for an example, there is a chance for the object to actually do work afterwards, no? Kasi yung spring natin kapag kinompress, no? Pag ni-let go mo, ano mangyayari? Mag-move yan, di ba? So meaning it does work. Okay? So if it can do work, so meaning of that is when you actually push it down, no? There is a stored energy or there is a potential for it to do work. Okay? So if it has potential to do work, meaning there is a potential energy that is stored within the object. Okay? So another thing, no, if the object is above, no, above ground, meaning nasa taas siya. Kapag nasa taas siya, anong meron? May chance siyang mahulog or mag-drop down, no? So kung mag-drop down siya, anong pwede? Anong mangyayari? Kung nasa taas siya, Kapag nag-drop down siya, there is a distance involved, there is a velocity involved, meaning, the potential energy then is stored kapag nasa taas sa kanya. Kasi meron siyang potential na mahulog eh. Di ba? Gets nyo ba yung, gets nyo ba yung logic niya? Okay? So, natin, ang tawag dito, the energy in position natin, or what we call the potential energy, is, the computation for that is, potential energy is equal to weight multiplied by height. If we have our weight, syempre, kapag nasa taas yan, there is what we call our gravitational constant. Okay? So, if there's weight, there must be gravity involved. Kasi pwede siya mahulog anytime eh. So, we have our PE is equal to mg multiplied by h. No? Or weight multiplied by height. So, pwede nating i-compute to. A mass of 100 kilograms is lifted on a distance of 50 meters. How much potential energy does it possess? Okay? Meron daw tayong isang object na 100 kilograms yung bigat niya. It is lifted on a distance of 50 meters. No? How much potential energy ang meron siya? Okay? Sige. I'll give you 2 minutes to try. Ito yung formula natin. No? If hindi nyo makuha, okay lang. If makuha nyo, maganda. Pero direct, lang naman, direct substitution. Try natin kung makukuha ninyo. If makuha ninyo, then we will proceed with number 2. Okay? Try lang natin. Okay? So, kung nakuha ninyo, paano ba siya sinagot? We have, balik natin doon sa pen ko. Yan, naka-pen na ako. So, mgh, no? So, mass is 100. Gravity is 9.81. Multiplied by your height, which is 50. So, we have, simple lang yan, no? Multiply lang. So, basic na basic. Multiplied by 50. So, that is 49,050, no? That is your joules. Okay? That is your, what? That is your joules, no? Yan yung stored na potential energy. So, next one natin. We have 70 kilograms diver standing on a driving platform, no? He stores up 3,500 potential energy. How high is the platform? So meaning, if the diver or yung nagda-dive, yung scuba diver or maybe a Olympics diver is actually standing above, no? He's standing above a swimming pool. So if he's standing above a swimming pool, is actually possessing a lot of potential energy because he will dive off, di ba? So how high daw is the platform? So we have our unit which is 70. Pwede nating i-substitute to sa calcu agad, no? 6,000 ay 3,500, 35,000 is equal to 70. We're actually acting on the gravity, which is 9.81. And you multiply it by your height. So height will be x. So if we shift solve for it, we're going to get 50.96, or if we round this up, this is 51. We have 51 meters, no? 51 meters is the platform, okay? So next we have the conservation of energy. Conservation of energy, the sum of kinetic energy and potential energy in a system is constant. In absence of friction, or Ke plus Pe is equal to constant, energy cannot be created nor destroyed. It may be transformed from one form to another, but the total amount of energy in a system remains constant. Anong ibig sabihin nun? No? Meaning, if there is an energy, for an example, nung kanina, kung yung diver natin nasa taas ng platform, if he actually jumped up the platform, there will be kinetic energy. Bakit? Kasi he has mass, then he will gain velocity from dropping down to the swimming pool. So meaning, there is actually kinetic energy that is involved. No? So that is your kinetic energy. So meaning, there is actually the law of thermodynamics, which is energy cannot be created nor transformed. Okay? So meaning of that, no? It will remain constant lang. Nagta-transform lang yung energy natin. Pero it cannot be destroyed. Okay? So, ito nga kagaya ng kanina, yung ano natin, yung diver natin, no? Magmula siya sa taas ng swimming pool, pag nag-dive siya pababa, no? He actually has energy. Okay? So kanina meron siyang energy nung nasa taas siya kasi he stores energy as a potential. Then if he dives off, oh, there's actually a kinetic energy because ang kinetic energy natin is 1/2 mv squared. The mass and the distance when he the mass and the velocity when he dives, no? Syempre may velocity yan, may bilis. There is a conservation of energy. Okay? To. So, ito, meron tayong a 10 kg boulder rests on the edge of 100-meter cliff. How much potential energy does the rock possess? Then the rock rolls off the cliff and falls to the bottom. How much kinetic energy does the rock possess at the bottom of the cliff? Okay. So if we're going to put this down, we have your 10-kilogram boulder rests on the edge of 100-kilogram cliff. So if this is 10 kilograms, then you multiply it by your potential energy or your gravity, which is 9.81. Then you multiply it on the height of the cliff, which is 100. Then your is 9.81. Then multiply it by 100. Then your potential energy is 9,810 joules, no? If he falls down the cliff, then if he falls down, we have another formula. Anong formula natin dito? Wait lang, nawawala yung pen ko. Ito. Hanap ko na. 1/2 mv squared. If he falls down, we can put it as 1/2 mass natin, which is 9.81. Ay, 9.81. 10 tuloy. 10. Then, V natin, our velocity is what? We have our 9.81 squared. Then, our potential, our kinetic energy is 481.18. No? Understand? Subukan natin to. May titingnan lang ako. 4,811. Okay. So, 10 times 9.81 times 100. 9,000. Ay, 100 pala yun, no? 1/2 m 10. Ay. V. This is 100 squared. So, we have 50,000, no? 1/2 mv squared pala. Kalimutan ko. Kasi lagi ako naka-focus sa 9.81. So, this is your kinetic energy, no? 1/2 mv squared. Okay? So, next natin. So, ay, iba 'to. Okay. So that will be your lesson for the work energy and kinetic energy, no? Napakadali ng lesson na 'to, honestly, no? So later on, I will post the assignments. So this is an asynchronous naman. Pwede niyong gawin anytime, no? Kasi siyempre alam ko maulan, the energy ay the internet connectivity is spotty, no? So I will give ample time to do ano yung ano natin, ano yung kailangan nating basa-basahin, no? Or i-solve. So yun lang. Mag-iingat kayong lahat, no? Napakalakas ng ulan. So kita-kits pag nag face to face ulit tayo, no? Medyo matagal na din tayo hindi nagme-meet.